Hi again, I'm Sambed Purohit, and today we are going to start with the second part of thermal properties of matter, that is thermal expansion in solids. Well, this thermal expansion, any or practically every solid expands on heating, more or less depending upon the material used. So now there are three types of thermal expansion in solids. So they are linear expansion, area expansion, and volume expansion. In linear expansion, there is increase in the length of the solid. So you can see that here. And in area expansion, as the name itself suggests, there is increase in area, and in volume expansion, there is increase in volume. So let's get on deeply into these. So now linear expansion. So this linear expansion, now there is increase in the length of the solid. So now let us consider a rod of uniform length. So this is the rod of uniform length of L. Now this is at temperature T. After heating, this rod increases its length to delta L. This is due to thermal expansion. Now this is the new length, that is L plus delta L. So now the coefficient of linear expansion, that is alpha, denoted by alpha over here, is defined as the change in length, that is delta L, per unit length L, per unit change in temperature. So now let us get on to say the unit of coefficient of linear expansion. Now delta L is in meters. So the SI unit of length is in meters. So now L is also in meter, and the SI unit of change in temperature, that is as well as temperature, is Kelvin. So now you can cancel M and M, so you get per Kelvin, or Kelvin to the power minus 1. This is going to be the same for all other two, that is coefficient of area expansion and the coefficient of cubic volume expansion. So now let us get on to the second one, that is the area expansion, or it is also called as superficial expansion. Now in this superficial expansion, there is increase in area of the substance or the solid. So now you can consider a thin metal sheet or something with area before heating, that is at temperature say T, to be A, and after heating, that is T plus delta T, that is increase in temperature. Then you get the area to be increased, that is A plus delta A. So now the coefficient of superficial expansion or volume area expansion is denoted by beta, and it is defined as the change in surface area, that is delta A, per unit surface area A, per unit change in temperature, that is delta T. So now let us get on to the SI or unit for that. So now area is in meter square, and now area also this again in meter square, and temperature in Kelvin. So you can cancel meter square and meter square, so you get per Kelvin. Now the next type of expansion, that is volume expansion. Here the name itself tells that there is increase in volume of the substance. So now you consider object with volume V here, and then on heating this volume increases. So that is called volume expansion. So now the coefficient of volume expansion, denoted by gamma, is defined as change in volume, that is delta V, per unit volume V, per unit change in temperature, delta T. So now again the unit, so delta V is in meter cube, V is also in meter cube, and delta T in Kelvin. So you can cancel meter cube and meter cube, so you get K power minus 1. So that is all about expansion or thermal expansion in solids. Thank you for watching. Enjoy physics.